So third question, once you know that it is linearly related, you will find the strength of that relationship, and what else? What type of relationship exists? So when it comes to type of relationship, we will be having two types. Generally, we classify that between simple and multiple. And simple relationship is of two types, positive and negative. So what type of relationship exists? And finally, what kind of predictions you can make? What kind of predictions can be made? Okay, so once you complete this section or the chapter 10, you must be able to answer these questions, right? Now, let me give you a real-time example or just a small example so that you can answer these questions. Now, let me say that I'm going to do a survey on dust storm and respiratory diseases. Okay, now I will keep this as x. This is my x variable, and this is y variable. Okay, so I have a plot x versus y. Now this is x and this is y. So as the dust increases, according to my survey, the diseases or the respiratory problems increases. So I will denote it by a line, straight line. Okay, so if x increases, y also increases. Fine. Okay, now let's answer these questions. Are these variables linearly related? I would say yes, because it has a straight line and there is a linear relationship. Linear relationship. Then, what is the strength of that relationship? Now, if you want to find the strength of any relationship between two variables, you have to first find out R, okay, which is called as linear. I'll just write it as LCC. That means linear correlation coefficient. Okay. Now, if you want to know the strength of that relationship, whether it is highly positive or highly negative, then you need to determine the R, and you know how to do that. Okay. Now, third questions, what type of relationship is that? Now, as I told you, there are two types of relationships, simple and multiple. Multiple, that means if you have more than two variables, that relationship goes to multiple. Now, since we have only two variables, we will say it is a simple relationship, and it is simple positive relationship. Why is it positive? Because if you move from left to right, the line increases. So if the line increases, we say it is positive relationship. And the R value has to be positive. Now, what kind of predictions you can make? So I just give you this plot, and if I tell you just make some random predictions, you can easily say that if the dust increases, the respiratory issues or diseases, I can say problems, the respiratory problems also increases. Okay, so it is very easy when you can draw the plot and make predictions. Fine, so this was your section 10.1, And this is why we need correlation and regression. So this is all about correlation, and we will talk about regression in section 10.2. I'll try to bring the similar kind of example so you can understand well. Fine. Now I had this plot, so I was able to make easy predictions, right? Now, likewise, you may not be able to draw a similar plot. So how did I make this plot? You will have some line, you will have some values here, okay? You will have some values here, here. It can be here, here, or somewhere here. So it can never be a perfect straight line. So you might get survey, you might get your results, which is not a perfect straight line. That's totally okay. But it has to have a resemblance of a straight line. That's what we need. Okay. Now, all you have to do is study about scatter plot, because scatter plot alone helps very much in correlation. Okay. Now in scatter plot, we have a term called as ordered pair. This is not a new one. Now what is ordered pair? That means if you can write x comma y inside a bracket, we call that as ordered pair. Okay, this is nothing new. So for example, let's say I have x and y, some values, let's say 1, 2, 3, 4, and I just gave here as this is my x and y. Now, if I tell you that write in an ordered pair, this is how you have to write. Ordered pair. X first, so 1, comma 1. This is a ordered pair. Next, 2, comma 4. You cannot write 2, comma 1. That is wrong. Okay? It has to be a corresponding values. So this is 3, comma 9, and this is 4, comma 16. So when you have a questions that says write in an ordered pair, this is how you have to write. Okay. So here, so I told you in previous class, I do not know whether you can see the picture so clearly, but I'll try to show. Okay, so this is from your blackboard. So you have formulas and tables given in the blackboard. I'm not sure whether you can access that or not. So this is table A6 that will give you the critical value R. Okay. So from this table you will find the critical value when it comes to chapter 10. So all you have to do is you can log into your blackboard PB9, and under test you have formulas and tables. And tables. So in this, just scroll down and you will find the table A6. Okay, and this is your critical value table. Now this is very important because you cannot find critical value for chapter 10 using a calculator. So you have to study this table. Study in the sense you do not have to mug up the values, but you must know how to use this table. Got it? Now it's very easy. I'll just give you an example here. Now you all know that alpha value will be given in the problem. So let's say your alpha value is 0.05 and the sample size is 5. Okay, alpha is 0.05, sample size is 5. Now you have two things here, alpha equal to 0.5, 0.05, and alpha equal to 0.01, and this is n. Got it? Now Now I know that alpha is 0.05, so I will choose this table, and n is 5, so 1, 2, the second row, n is equal to 5, and alpha is 0.05, so my answer is critical value R will be equal to 0.878. Okay, now one important thing here is the sign of the value. So when it comes to correlation, we denote by rho. This symbol is called as rho. Okay, now let's say your H naught is equal to 0 and your H1 is not equal to 0. The null and alternative hypothesis. Now, when it is not equal to 0, it is a two-tailed test, right? Now, when you have a two-tailed test, I told you that there will be two values, plus or minus. Okay, most of the time in your chapter 10, you will definitely have this kind of relationship. Your alternative hypothesis will always be not equal to. And why is that? That is because your question is, now we know that we are studying about correlation, then what would be the claim when you are studying about correlation? There should be only two things, whether yes or no, whether it is a linear relationship or not a linear relationship. So it has to be equal to or not equal to. Get it? So it cannot be greater than or less than. It is most probably be this kind of problems. And that is why null and alternative hypothesis will have this symbol. Got it? Okay. So next is, okay, they are asking us to construct a scatter plot. I will show you for one and you can do for rest of them. Now, whenever they ask you to construct, just draw a line. It could be a rough diagram. This might not be your test problem, but it's good to know. Okay, now always you will take x, the first variable as x and the second column as y. Got it? Now we know it is from 8.5 to 63. I will just give a random number 8. Let's say I have 13 here, 20, 29, 63. And likewise, I have 1 here, 2, 3, 4, 5, 6, and 7. Okay, so all you have to do is just join the points. Now x is 63, y is 7. So where is 63 for me? Here is 63 and y is 7. So 63, and you will cut here at 7. You have a point. Okay. Now likewise, if you do for another values, 29 here, 3.9 here, this is just a rough diagram, 20 here, and is 2.1 here. We have 19 and 2.8. Somewhere here. 13.4 and 1.4. 8.5 and 1.5. Okay, so this is called as a scatter plot. Now, if you join this line, now the points are very close to each other. So when you take a long scale, if you bring as close together, this will bring you a straight line. So it cannot be a perfect straight line, as I said you. It could be something like this. Okay. Now from this, what can you infer? So this is increasing and we have a positive relationship. So scatter plots helps us a lot in understanding the correlation. Got it? So always there is no need for you to calculate the R value and then find out the relationship. You can just plot the scatter plot and then check for the relationship. Okay. So this is one way to identify the correlation. Okay. Now for the same example here, let's calculate your okay. For the same example, I want you to calculate R. You just have to use your calculator. Okay. I'll just give you the steps here. You can follow. So use your calculator to find R. Calculator. Just press second. You have to turn the diagnostic on first and then you have to do the rest. 2 and then 0 or catalog. And then you have to scroll to this diagnostic on. So you have to press enter twice. Okay, enter twice because you will see the done word once you enter. Okay, so after you do this, click on start, edit, and you will enter the values in L1 and L2. Enter the values in L1 and L2. So once you do that, again go to start, test, RAGTTES. A small correction here. You can do this also, but we actually learned this in our class. And then you enter L1, comma L2, and then click on enter. Look at the table. Do this and tell me the R value. If you're getting only A and B, that means you have not done the step. Okay, you can just go back and do this step and again come back to the third step and redo it again. So they're saying that R value is 0.982 in WebEx from Erica. Did anyone get the same value? So this is the answer. Okay. So once you do this, let us also do test hypothesis testing. Okay, we will do hypothesis testing for the same problem. Okay, so I will teach you this and you can do the rest of the example on your own. Now, step 1, we will write h0 and h1 as rho equal to 0, rho not equal to 0. Rho in the sense we are finding correlation, so this is called as rho, RHO. Okay, now step 2 is to find the critical value. Now you have to go back to the table and find critical value. So here alpha is not given, so just take it as I'm going to give you the alpha. So 0.05 and n is what? 1, 2, 3, 4, 5, 6. So n equal to 6. Okay. Now you have to tell me critical value of R. So it is always plus or minus. I will show you the table here. Alpha is 0.05 and n equal to 6 and tell me the value. 0.811 because n is 6, alpha is 0.05. The value below that is 0.8911. I know it's not clearly visible. So alpha, the critical value is 0.811. Okay, so next is to find, step 3 is to find the test statistic. Now you do this using the calculator. Now to find the test statistic and p-value, you just have to do one step and that will give you both these values in your calculator. Just give you the steps here in a calculator. Stat, edit, and you are going to enter L1, L2, and once you do that, go to stat, test. Here you will have E, option E. So there you have LENREGT test. So if you do this, I guess you don't have to enter anything. Okay, you will have L1, L2. Yes. The claim will depend on your decision. Okay, it depends on whether you're rejecting or not rejecting. Okay. So once you do this, the statistics and find the p-value, you will get your answer. So do this step and tell me the answer. I will show you the column here. Just note down the steps in a notebook and then I will show you the question. Okay. And this is the question. You have to enter this as L1, this is L2. Done? Anyone with the answer? Okay, so that's your p-value, or so you got p-value as 4.841. Okay, you get 0.00005. How many zeros? Any other answers? Okay, you click on Stat, Edit, and you have to enter L1 and L2. So it is T3, 29, 20.8, 19.1, 13.4, and 8.5. And L2 is 7, 3.9, 2.1, 2.8, 1.4, and 1.5. Okay. And then I go back to Stat, Test, and then I just scroll down and find LENREGT test, and then enter. So L1 is there, L2 frequency is always 1, then we have not equal to 0 and equal to 0. So that's also correct. You don't have to enter anything and calculate. You get P as 4.84 to the power of -4. So your answer was right, but you were supposed to just write 10 power -4 also here. So rounding it off, then we will get P as 0.0005. I mean 48, just round off, we get 5. Okay, so this is your p-value, and you're going to compare this with alpha. Alpha I gave as 0.05. Okay, now p-value is less than alpha. Okay, when p-value is less than alpha, we say reject H naught. That's your initial conclusion. That's your initial conclusion, and your final conclusion. When you are rejecting H naught, you say there is sufficient evidence and there is no linear relationship. So the claim is H1. Okay, so this is how you have to to the hypothesis testing. Now, you can just note down the steps if you want. Do you want to take a picture? Okay. So before I do this, let us do one more example. I will just so this is the example which we did in our previous class. Let's do it again. So this is one more example. I will give you x and y. 73, 69, 58, 48, 84, 62, 57, 45, 70, 63, and 48. And your y is 6.2, 4.2, 1.9, 2.7, 5, 1.6, 1.6, 3.5, 2, and 3.7. Okay, so this is your x and y. Okay, so let us do hypothesis testing for this. Okay, so this is your first step is to state h naught and h1. H naught will be rho equal to 0 and h1 will be rho not equal to 0 always. Okay, now alpha, take it as 0.05 and n is how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n equal to 11. Okay, so next step is to find the critical value r, and it will be plus or minus. So you have alpha is 0.05, n equal to 11. Go back to the table here. Alpha is 0.05, n equal to 11. If you can't see the value, just give me the rough value. So alpha is 0.05, n equal to 11. The value here is 0.602. Okay, you can also take a look at your blackboard. So we have critical value as 0.602. Okay, so once this is done, we will find test statistic value. So here we need a test statistic and p value. So you get both r and p. So all I need is p value. So I want you to calculate p here. So the steps are go to stat, edit, fill L1 and L2, L1 and L2. Again go to stat, test, and you choose option E, LENREGT test. Do this and tell me the answer. You could tell me the R value if you want. So all we want is finally the P value. You did. That's the p-value. Answer p-value 0.103. And what is the R? Okay, let's compare both. Okay, now that I have p-value and also R from critical value and test statistic, we also have alpha. So all we do is comparing p-value with alpha. So p-value which we got is 0.103, alpha which is there in the example is 0.05. So 0.1 is greater than 0.05. Also, you can also compare the critical value R with the statistic value R. Okay, critical value which we got is 0.602, just always take a positive value. The statistic R is 0.517. Okay. For example, if you have a negative 0.517, then critical value, you choose negative 0.602. You compare positive with positive, negative with negative. Negative. Now 0.6 is greater than 0.517. So you don't have to do the second one, that's just optional. You can always do the p-value. Okay, now since p-value is greater than alpha, our initial conclusion will be fail to reject H naught, fail to reject H naught, and our final conclusion will be there is insufficient evidence conclude that there is a linear relationship. Okay, so when we have failed to reject H naught, that means we do not have a linear correlation. So when this is one example, and here we got this is failed to reject H naught, this is reject H naught, that means there is a linear correlation. This is a small correction. There is a linear correlation. Linear correlation. Okay. So example one, which we did through the scatter plot, right? So here we concluded there was a linear relationship because it is a straight line. Now, in the same way, we did hypothesis testing and we got the same conclusion. Okay. So this was another example, example 2. And you have one more example here. You can go ahead and do the same thing. So all I want you to do is, first one, construct the scatter plot. A rough diagram is fine. Construct scatter plot. And next is find R using your calculator, and there you have LING REG A plus BX diagnostic on, you will get R. So in the same way you do hypothesis testing. And finally conclude a about the relationship, whether you have a relationship or not. So I want you to do these four things using X and Y for this example. So I have not done this, so it depends on the answer you tell me. Yes, the R which you get from the calculator is a test statistic value, and the R which you get from critical value is from the table, so it will be different. So take alpha as take alpha equal to 0.05. Done. Okay. So what's the R value you got here? R equal to 0.944. Is it a positive or negative? Positive? You got positive? It's negative. Okay. And we need this. Okay. So all I need is the critical value R, the test statistic value P value. How much did you get? Critical value R. Alpha equal to 0.05 and N is 7. Do you want me to show the table? 0.754. Anyone with the same answer? Okay. What about P value? 0.001. And when you compare this with alpha, that is equal to 0.05. So P value is less than alpha. Then what would be your initial conclusion? So what is the initial conclusion if P is less than alpha? Reject, it's not. And final conclusion. There is sufficient evidence. And what about the relationship? Is there a linear relationship? Yes. There is a linear relationship. Okay, so this is how you have to do the hypothesis testing. Now I have a couple of examples below. I'll just post those notes in the blackboard. You can find it in BO1 section. Okay, so I want you to do this example and practice as much as you can, because this is all about using the calculator. Yes.
We have an exam next week, don't we? And are we going to review it on Friday?
I'm planning to do that. Let's see. I'm just picking the schedule.
Okay.
It's an announcement.